Okay, welcome to 3.5 and 3.6. We're going to talk about some bisectors in triangles and some other important segments. So the first one is a perpendicular bisector, and that is just a line that bisects a side. So if you notice, this side is being bisected, we have our tick marks there, and it's also perpendicular, right? So the two important pieces is that it bisects, meaning it splits the side into two congruent parts, and it's perpendicular, so it forms a right angle. Okay. If we have a perpendicular bisector, so if we look at this picture here, PM is our perpendicular bisector, and what that tells us then is that AP and PB have to be the same length. Okay. So when you see something like that, we also know that AM and MB are the same length. Again, you should see those tick marks. But then it also tells us that PA is equal to PB. Okay, next up we have an angle bisector. So this is just a line, ray, or segment that divides the angle into two congruent parts. So hopefully here you can see that we have these arc marks that show that those two angles are congruent. So AB is a segment that would divide angle CAD into two equal parts. So again, just something to keep in mind when we have that. So in this picture down here, QS is our angle bisector, and so this side is the same as this side, those angles. When we have that, we also get these parts that are congruent. So SP would be the same as SR. Okay, so let's look at just a couple quick examples of this. This first one is quick. So this is a perpendicular bisector here because we see the right angle and we see those two congruent tick marks. So if AD is 7, right, that makes DC 7. So AC, the whole thing, would have to be 14. Okay, again, that's because we know that those two pieces are congruent, so they have to be the same length. Okay, and the second one, again, we have a perpendicular bisector. We see the two congruent parts in the right angle. And so that tells us then that AB has to be congruent to BC. So we know anytime two things are congruent, we're just going to set those two things equal to each other and solve for x. So I'm going to bring over the 6x. Don't forget about your negative signs. And so x equals 5. However, it's not asking us what x is, it's saying what's AB. So make sure you go and plug that in. So I plug in 5 for x. 4 times 5 is 20. Okay, here it's saying in triangle MNP that MO bisects the angle. So that is a angle bisector, which tells us that angle 1 is congruent to angle 2. And so if angle 1 is 33 degrees, the measure of angle 2, pretty straightforward, has to be 33 degrees. Okay, again, because of this part, that's telling us that it's an angle bisector. Same idea, except now we have some expressions to use. So again, it's saying SU is an angle bisector, which makes this part congruent to this part. Anytime we know two things are congruent, we set them equal to each other. So I have 5x equals 2x plus 15. Solve for x. So bring your 2x over. Divide by 3. And x equals 5. Again, not our final answer. We want the measure of angle UST. UST, that's this angle here. So I'm just going to plug in 5 for x. So 5 times 5, that is 25 degrees. Okay, so that is our final answer. Okay, last two types of segments that we're going to talk about is a median. A median just goes from the top, the vertex of a triangle, to the midpoint of another side. So you can see that we're creating these two congruent parts. It doesn't have to be perpendicular like a perpendicular bisector. It's just connecting vertex to midpoint of a side of a triangle. Okay, now one important thing to note, I could draw in a median from every side. So vertex to midpoint, I could have one that way, right? And I would get two congruent sides there. And then I could also have vertex to midpoint this way, right? And then again, two congruent sides. So you can have 3 medians total in any triangle. Lastly, we have an altitude. An altitude is a perpendicular segment that goes from the vertex of one perpendicular, so forming a right angle with that opposite side. Okay, so this one we don't know anything about. It's not going to the midpoint necessarily. It's just forming a right angle. And because it has to form a right angle, if you look below this, we have some different scenarios. So in an acute triangle, right, it's going to go straight top to bottom. So it's going to be inside the triangle. Okay, but in a right triangle, because you have to go from the vertex to form perpendicular with the side, it's going to go right along the side of the triangle. The third scenario, in an obtuse triangle, you could have it actually outside the triangle because, again, it has to go from the vertex straight down to be perpendicular with that side. Okay, so different ways of seeing it, but they are all altitudes of a triangle. And so that is it for 3.5 and 3.6.